Hello everyone, welcome back to channel Civil Engineering Academy. In today's video, we are going to learn about the parts of a tacheometer. A tacheometer is basically modified theodolite that help us to measure horizontal distances, elevations and the differences in the height quickly without using chain and tape. So the very first and most important part is a telescope. It is used for sighting the shaft and magnifying the image so that we can read the shaft clearly. The telescope consists of three main components. The first one is the objective lens, which collects the light and forms an image of the shaft. Then another part is the eyepiece, which magnifies this image so we can see it clearly. And then next is a focusing screw, which is used to adjust the lens to get a sharp and a clear view. Actually, there are two types of a telescope: a simple telescope and an analytic telescope. A simple telescope which requires us to use the full formula including the multiplying constant k and the additive constant c. But an analytic telescope which has an extra lens inside it is called as an analytic lens. This means it removes the additive constant so the calculations become simpler. Most of the modern tacheometers are an analytic telescope because it saves the time and reduces calculations error. So this is all about the telescope of tacheometer. Then another component part is a diaphragm. Inside the telescope there is a thin glass screen. It's called as a diaphragm, or we can say it is a reticle. This diaphragm carries the crosshairs. In tacheometer it has a one vertical hair and three horizontal hair. And the central hair shows the main line of a side, and the upper stadia hair and the lower stadia hair are the fixed at equal distances above and below the central hair. So when we observe the shaft through the telescope, we have three readings: top, middle and the bottom, and the difference between the top and the bottom reading is called as a shaft intercept, and it is used in the tachyometric formula to calculate the distance. Now the next component part is a vertical circle, which we also call as altitude circle. It is a graduated circular arc attached to the telescope, and this part measures the vertical angle of the line of sight, whether we are looking upward or the downward. And this angle is very important in the tachyometry, especially on the sloping ground, because it helps to calculate the horizontal distances and the elevations of the observed points. Now the next component part is a stadia leveling bubble. On the telescope there is a small spirit bubble tube called as a stadia leveling bubble, and it ensures that the line of sight is perfectly horizontal whenever we need it to be, and it works just like the bubble in the dumpy level or an auto level. Then the next one is the leveling head. The leveling head is present at the base of the instrument and consists of flat leveling plate and the 3 or sometimes 4 foot screws. By adjusting these screws, we can make the vertical axis of the instrument truly vertical, and this provides a stable and level base for all the measurements. Then the next component part is a compass box, which is totally optional. Some tachyometers come with a small compass box attached with it, and this compass helps in the measuring the magnetic bearing of survey lines directly. It is especially useful in the preliminary or the reconnaissance survey, where the directions are also required along with its distances. So this is about the compass box, which is optional in the tachyometric surveying. Now the next component part is a tripod stand. The tripod stand supports the entire instrument, and it has a 3 legs made up of wood or the lightweight metal, and each ending is a pointed shoe so it can be fixed firmly into the ground. And the height of the tripod can be adjusted according to the surveyor's convenience, and a stable tripod is essential for the accurate measurement. Now the next component part is a focusing and the tangent screws. On the telescope, we have the focusing screws, which brings the shaft image into the clear focus, and there are also tangent screws provided for both horizontal and the vertical movements of the telescope, and these screws allow very fine and the precise adjustment so that we can align the line of sight exactly on the required shaft point. Now the next component part is the analytic lens. In an analytic tacheometer, there is an additional lens called as an analytic lens fitted between the objective lens and the diaphragm. And its main purpose is to eliminate the additive constant from the formula used to find the distances. And this makes our calculation much simpler and reduces the chances of error. Now the next component part is a staff. Finally, let's talk something about the staff. Actually, it is not a physical part of a tacheometer, but it is an essential accessory for the tacheometric work. The staff is usually made up of wood, aluminium, or the fiberglass, and it is graduated in the meters, decimeters, and the centimeters, and it's generally 3 to 5 meter in the long. Some staffs are 3 meter long, 4 meter long, 5 meter long, like that. The staff is placed vertically at the point where the distance or the elevation is to be measured, and the readings corresponding to the upper seria here, central here, and the lower seria here are taken through the telescope to compute the distances and the elevations. So these are the different component parts of a tacheometer. So we'll quickly recap all the component parts like telescope, diaphragm, seria hairs, vertical circle, seria leveling bubble, leveling head, compass box, tripod stand, focusing and the tangent screws, the analytic lens, and the finally staff. Each of these parts has a specific functions, and together they make the tacheometer very efficient instrument for the rapid surveying. In our next video, we will learn about the principle and the working of tacheometry. So, if you found this video useful, don't forget to like, share and subscribe to our channel for more educational content in the civil engineering. Thank you.